Problem 28. A typical acoustic guitar has a range of 3 octaves. When the guitar is tuned to concert pitch, the range of frequencies for those 3 octaves is between 82.4 Hz and 659.2 Hz, inclusive. Write a compound inequality to show the frequencies that are within the range of a typical acoustic guitar. Graph the solutions. So if we let F represent the frequencies of an acoustic guitar, we can say then that the frequencies are going to be less than or equal to 659.2 and greater than or equal to 82.4. 82.4 Hertz. And the way we would graph this inequality, this is a conjunction, so it's in between, and it's inclusive, so we would have 82.4 on this end, we would have 659.2 on this end, and the line in between would be darkened to show that any of those frequencies are within the range of a typical acoustic guitar. Alright, so from 30 to 33, I'm supposed to write and graph a compound inequality for the numbers described. So all the real numbers between -6 and 6. Well, if we let x be all the numbers between 6 and -6, we'll have 6 on this side, -6 on this side. So it's going to be x is going to be less than 6 and greater than -6. And if I show the graph on that, it's going to be an open circle at 6, an open circle at -6, and all the points in between. So this would be darkened. Okay? Now, all real numbers less than or equal to 2 and greater than or equal to 1. So, so think of this. I'm going to have x, so it's going to be greater than or equal to 1, and it's going to be less than or equal to 2. So this is going to be a closed circle at 2, a closed circle at 1, and we're going to darken the line showing that any one of those points in between those numbers, as well as the numbers themselves, will make that inequality true. 32, all real numbers greater than 0, and, so it's an and less than 15. So so it's going to be x again, representing all the numbers, real numbers. So it's going to be less than 15, right? And it's going to be greater than 0. So this is going to be an open circle at 15, open circle at 0, and we're going to darken the points in between. Here we go, all real numbers between -10 and 10 inclusive. Between -10 and 10 inclusive. So again, there's an and. So here's -10, here's x, here's +10. Inclusive means including, so we're going to be equals to. And so this is going to be a closed circle, a line in between, and darkened like so. 33. All right? Number 34. The cruise control function of a car should keep the speed of the car within 3 miles an hour of the set speed. Write a compound inequality to show the acceptable speeds if S is set at 55. So think of this, if it's 3 miles an hour either way, so if S is the speed, so it could be, if I go 3 miles an hour faster, that's 58, right? 55 plus 3 is 58, so S is going to be less than or equal to 58, and then if it's 3 miles an hour slower, 55 minus 3 is 52. So it's going to be greater than or equal to 52. And then graphing that solution, this is going to be a darkened circle. That's going to be a darkened circle at 52. So we have 58, we have 52, and it is all the points in between represents the S. Okay? Now, so 35, water is not a liquid if its temp is above 100 degrees Celsius or, there's the trick, it's the or, below 0 degrees Celsius. Write in a compound inequality for T being T for temperature, showing this. So T is either going to be, so T is going to be below 0, so either T is less than 0 or T is greater than 100. All right, and the way this would look on my number line, here is 0, here is 100, be an open circle at both. This darkened line would extend to the right, this darkened line would extend to the left.